Alright guys, here we are for another example. This is going to be how we translate a parabola. So this is going to be how we shift a parabola. Either we're going to move it up, down, left, or right somewhere in the coordinate plane. Now this procedure is going to be the exact same for any parabolic equation. It'll be the exact same method on how we do it. But just for simplicity's sake, I've started us off here with the easy equation of f of x equals x squared. So it could this procedure will work for 3x squared or 1/2 x squared or any other parabolic equation, but I'm just using y equals x squared as the easiest, most simple example. That way we can get the main idea across. And again, don't forget that f of x is really the same thing as y. I've got f of x equals x squared here, but that's the same thing as saying y equals x squared. Alright, so let's start with our first example here. I've got my equation, y equals x squared, and I'm going to want to shift this parabola up 2 units. So I'm going to move it up 2 units. Alright, so again, we're shifting it up 2 units. So just to remind you what the transformation notation looks like for that, we would have that written as x comma y. We have our little arrow, goes to x comma y plus 2, indicating that we want to raise the y value by 2 for every point on this curve, right? Awesome. So now actually physically doing this is not that difficult. All I'm going to do is I'm just going to go to my parabola, and I'm going to look for places where I see that it intersects perfectly with my grid lines, and I'm just going to go to there, and then I'm going to go up 2 units from that point. I'm going to place a new point. So from origin, I'm going to go up 2 units, place my point here. I see I have a good intersection at 1, 1. So I'm going to go there. I'm going to go move it up 2 units. 1, 2. Put a point. I see the same at -1. So I'm going to go to -1, 1. And move it up 2 units. Put a point. And again, all I'm doing is I'm just shifting these up 2 units up from their original position. That way I can get my new parabola. And then here, let's see, I'll use this point here. It goes up 2 units. Be about right here. And 2 units from this point would be about right here. Awesome. So now I'm going to go ahead and just connect my dots. And I have translated my parabola. There we go. So actually doing the physical translation is not that difficult, but what's kind of more valuable is actually to be able to use the translation to come up with a new equation. That way we can use this data to model and make predictions for the future. So let's take a look at it. I'm going to clean that up a little bit. There we go. So I have my equation, y equals x squared, and I've drawn it up here. So now let's come up with the actual new equation for our new parabola. Again, the old equation was y equals x squared, so we're going to start with that. Now, we moved the whole function up 2 units. So that means that y should be higher for every value of x. So every single value of x, we need to increase the value that it currently is by 2. So that's not too bad, actually, if you think about it. If we just want to increase all the values of x by 2, well, we can just add 2 to the end of it, right? So if we have y equals x squared, we want to go make all those values go up by 2, well, just add 2. So our new equation would be y equals x squared plus 2. And alternatively, you could write that as y minus 2 equals x squared. It's the exact same thing. Just subtract 2 from both sides, and it's the exact same equation. So again, if we're trying to translate our parabola 2 units up, all we have to do is add 2 to the end of the equation, or subtract 2 from our y value. And that's how we move it up. And likewise, if we want to move it down, well, we're just going to subtract 2 from the end of our equation, or we would add 2 to the y value. So now that's the up and down case for parabolas translations. Let's look at moving a parabola to the left or right. Let's say I want to move a parabola 3 units to the right, okay? So the actual physical translation of this parabola on the coordinate plane, again, is going to be very similar to the last method. It's very clear. This translation notation is saying we're going to take our x units and we're going to increase them all by 3. And that's all we have to do here. So we're just going to go through all of our points, and anywhere we see a point, we're going to take that point and we're going to move it 3 units to the right and we're going to put a new point. That's it. So let's do it. I'm going to start here at 0, 0. I'll move my new point will be then at 3, 0. Put a point. 1, 1. I'd add 3 to the x, so give me 4, 1. Negative 1, 1. Add 3 to that, and I will get 2, 1. Let's take a couple other points, like right here. It's a good one at 2, 4. I'm going to add 3 to that, and I'll get 5, 4. And at negative 2, 4, if I add 3 to that, I'll get 1, 4. So I have enough points now for me to go ahead and draw this curve out. I'm going to go ahead and draw it. There we go. And that's our translation. Again, it's pretty cut and dry for the physical translation on the coordinate plane. I think the more difficult part is the actual coming up with the equation. So let's look at making the equation for this parabola. So again, we're going to start with our base equation. This base equation was y equals x squared, so I write that down here, y equals x squared. And for this one, it's a little bit different. What's going on here is, well, what I like to do is I like to try and think of it like this. I know that normally with y equals x squared, well, when x equals 0, y equals 0, right? Because 0 squared is 0. If we want to look at our new parabola over here to the right, we see that, well, when x equals 3 is when y equals 0. So we need to change this equation some way. So that way, whenever we square this value of x, that it's going to equal 0. And we know that the only thing times itself that equals 0 would be 0 itself, right? So we need to somehow find a way to cancel that x out, somehow a way to get rid of that, right? Well, let's look at it. At point 0, 3, we see it's at point 0, 3 that that point is 3 units over to the right. We want y to equal 0 when x equals 3, right? All right, well, currently, if I plugged a 3 in for x in this equation y equals x squared, I get y equals 3 squared, which is 9. Okay? Got it? But what I want is y equals to be 0. So I have y something squared. I need this to become 0. Well, what can I do when this x is a 3? I need to make this equal to 0. So what can I do to that value of x? Well, I can subtract 3 from it. That's right. So that way, when x equals 3, like it does in our curve here, we'll have 3 minus 3 equals 0. And 0 squared will be 0. So y will equal 0. So that gives us the equation y equals, in parentheses, x minus 3 squared for our new equation. And let's check that. Let's go ahead and plug in a 3 back in for that value of x to make sure that it does indeed come out to be 0. If I plug a 3 in for this, I get y equals 3 minus 3 squared, and 3 minus 3 equals 0, and 0 squared equals 0. So yes, we did it indeed. This is the equation, y equals, in parentheses, x minus 3 squared. Awesome. Hey, so let's summarize this up really quick. If we're trying to shift a parabola up, all you're going to want to do is add however many units you're shifting it up to the very end of your equation, or alternatively, you could subtract it from the y value. If we're trying to shift a parabola down, just subtract from the end of the equation, or alternatively, you can add to that y value. If we're trying to shift a unit parabola to the right, this is a kind of tricky one. Remember, you're going to have to actually subtract from the x value, which is kind of counterintuitive. So again, if you're shifting it to the right, you subtract from the x value. If you're trying to shift it to the left, you actually add to the x value. All right, guys, hopefully that helped clarify anything. If you guys had any questions, if not, please show up during the Zoom session today. I'll be happy to help you guys out. Awesome. I'll see you then.